Hey there, ever step outside on a summer day and just immediately feel sticky? You know, that thick, heavy air that just hangs around? Well, today we're going to get to the bottom of that feeling. We're demystifying humidity, and what we find might surprise you. So you pull up your weather app and you see that big number, 70% humidity. Seems pretty simple, right? But what if I told you that number is, well, it's kind of misleading. It's probably one of the most misunderstood things in all of weather, and it is definitely not the best way to know how humid it's actually going to feel outside. So here's how we're going to crack this case. Think of it like a little investigation. First up, we'll look at our main suspect, relative humidity. Then we're going to uncover a major plot twist involving temperature. After that, we'll introduce the real hero of our story, the dew point. We'll see how they stack up, and finally, we'll talk about why any of this actually matters to you.
All right, let's get into it. Our investigation begins with the clue everyone thinks they know. Our first piece of evidence, relative humidity. We see it everywhere, but honestly, it's where most of the confusion really begins.
Yep, we've all heard it. It's on the news, on our phones. But here's the real question. What is it actually measuring? Because, and this is the kicker, it's not telling you how much water is actually in the air. I know, that sounds a little crazy, but stick with me.
The biggest clue is right there in the name, relative humidity. That word relative is everything. It means this isn't a fixed amount. It's a comparison. It's a ratio.
So what relative humidity is really telling you is how full the air is with water vapor. The best way to think about it is like a loading bar on your computer. Is the air 50% full, 70% full? It's not telling you the total amount of water, just how close the air is to being completely maxed out at its current temperature. Let's make this super clear. Imagine the air is like a big jug, and at today's temperature, that jug can hold, let's say, 20 grams of water vapor. If there are only 5 grams in there, the jug is 25% full. That's 25% relative humidity. Now, if we add another 5 grams, we're at 50% full. Simple enough. And if we keep going until it's about to overflow, boom, that's 100% humidity, or what meteorologists call saturation. And you've seen this happen all the time. Think about taking a long hot shower. You're just pumping steam, which is just water vapor, into the bathroom. Pretty soon, the air in there is completely full. It literally cannot hold another drop. It's at 100% relative humidity. So what happens to all that extra steam? It has to go somewhere, and it finds the coolest surface around, your mirror. That's why it fogs up. Okay, so far so good. But here's where our investigation takes a huge turn. This is the plot twist. This is the reason relative humidity can be so incredibly deceiving. And it all comes down to one thing: temperature. So let me ask you this. What do you think happens if the amount of water in the air stays exactly the same, but the temperature changes? Because here's the secret. The air's ability to hold water isn't fixed. Warmer air can hold a ton more water vapor than colder air. So what happens when that temperature drops? Okay, check this out. Look at this table. On the top row, we've got air at 20 degrees Celsius. It's got 7 grams of water in it, which makes it 50% full, or 50% relative humidity. Now, that's not touch the water. We leave those 7 grams right where they are, but we cool the air down to 10 degrees. Suddenly, that exact same air is at 100% relative humidity. Nothing changed about the actual moisture, but because the air got colder, its capacity to hold water shrank, and now it's completely full. Wild, right? And this isn't some weird science experiment. This happens literally every single day. Think about it. In the cool morning, the temperature is low, so the relative humidity is usually high. But as the day gets warmer in the afternoon, that number actually goes down. It's not because water magically disappeared, it's because the warmer air can just hold more, so it feels less full. And that right there is the big takeaway. Relative humidity and temperature are like a seesaw. If the amount of moisture in the air stays the same, when the temperature goes up, the relative humidity goes down. And that's exactly why it's such a tricky way to judge how muggy it's going to feel. So if relative humidity is our misleading suspect in this case, who's the hero of the story? Well, allow me to introduce you to the dew point. This is the number that gives you the honest-to-goodness truth about how much moisture is really in the air. You see, dew point isn't a percentage or a ratio. It's much simpler. It's a temperature. It is the exact temperature the air would need to cool down to for dew to start forming on the grass. That's it. And here's the most important part. A higher dew point always means there's more moisture in the air. No ifs, ands, or buts. Period.
And here's why that's so awesome. You can use it as a direct comfort guide. If you see a dew point under 60 degrees Fahrenheit, that's about 15 Celsius. It's going to feel pretty comfortable. Once it creeps up over 65 Fahrenheit, or 18 Celsius, yep, that's when things start feeling sticky. And if you ever see a dew point over 75 or 24 Celsius, that's when you know it's going to be truly oppressive out there. Okay, so it's time to bring our two key players, relative humidity and dew point, together for the final verdict. The case of what makes the air feel humid is officially closed.
So, here's the final verdict, the bottom line. Relative humidity, it's just a ratio. It's totally dependent on the temperature, and all it tells you is how full the air is. But dew point, that's an absolute measure. It's an actual temperature, and it tells you exactly how much moisture is in the air. And that's what you can actually feel.
Okay, so now you've cracked the case, but you might be wondering, all right, that's cool, but why does this really matter? Well, this knowledge actually explains some very common things you probably experience all the time. First up, why do your lips always get chapped in the winter? It seems kind of weird, doesn't it? It's cold and damp outside, but inside your house, your skin gets so dry. It feels completely backward, but our new understanding of humidity explains it perfectly. Remember, cold winter air just can't hold much moisture to begin with. So when you bring that air inside and your furnace heats it up, you dramatically increase its capacity to hold water. The actual amount of water hasn't changed, so the relative humidity just plummets. And that super thirsty dry indoor air starts pulling moisture from wherever it can find it, including your skin and your lips. All right, here's another one. Is frost just frozen dew? I mean, it makes sense, right? Dew forms on the grass, then the temperature drops below freezing and poof, you get frost. It seems pretty logical. But surprisingly, nope, that's not what happens at all. Frost forms when the dew point itself is below freezing. This means the water vapor in the air skips the liquid phase entirely and turns directly from a gas into a solid, into those beautiful little ice crystals. And this really cool process has a name. It's called deposition.
So there you have it. The mystery is solved. Relative humidity tells part of the story, but the dew point tells you what you really want to know, how humid it's actually going to feel. So the next time you open up that weather app, I hope you'll look right past that big percentage and find the dew point. It is the real secret to understanding that sticky summer air. Thanks for tuning in.